Hemostasis. Hemostasis refers to the spontaneous arrest or prevention of bleeding from the injured or damaged vessels by the physiological process. It involves three main steps: vasoconstriction, formation of temporary hemostatic plug, and formation of definitive hemostatic clot. Vasoconstriction. Initial vasoconstriction is caused by the direct effect of injury on the vascular smooth muscles. The initial vasoconstriction is transient, but is maintained for several minutes or even hours by humoral facilitation due to release of 5-hydroxytryptophan and other vasoconstrictors. Formation of temporary hemostatic plug. Formation of a temporary hemostatic plug by the platelets at the site of injury involves the following steps. Platelet adhesion. Following injury, platelets come in contact with the damaged collagen fibers and endothelial cells of the vessel wall and change their characteristics. That is, they begin to swell and assume irregular forms with large number of pseudopodia protruding from the surface. The contractile proteins of the platelets contract forcibly and cause release of granules that contain multiple factors. They become sticky and therefore adhere to the collagen of damaged cell wall and to the damaged endothelium. Platelets activation. The platelets secrete large quantities of ADP and thromboxane A2, which act on the nearby platelets and cause their activation. Stickiness of these additional platelets causes them to adhere to the originally activated platelets. In this way, a various cycle is initiated which leads to activation and adherence of large number of platelets. Platelets aggregation. The large numbers of activated sticky platelets stick, forming platelet aggregation. Platelets aggregation is also increased by platelet activating factor, a cytokine secreted by neutrophils, monocytes, and platelet cell membrane lipids. Platelet aggregation initiates a series of reactions which results in formation of thromboxane A2 and prostacyclin from the platelet membrane phospholipids. An important point to be noted here is that aspirin prevents platelet aggregation by inhibiting the formation of thromboxane A2. Therefore, aspirin in low doses is of value in preventing myocardial infarction. Formation of a temporary hemostatic plug. The platelet adherence and aggregation ultimately lead to the formation of a platelet plug. At first, it is a fairly loose plug but is successful in blocking the blood loss if vascular opening is small. Inhibition of further plug formation. Prostacyclin formed from the membrane phospholipids inhibits thromboxane formation and thus curtails the process of further plug formation. This reaction keeps the platelet plug localized, that is, prevents intravascular spread of plug. Formation of definitive hemostatic plug. The temporary platelet plug is converted into the definitive hemostatic plug by the process of clot formation, which involves a complex series of events. Platelets play an important role in the formation of the intrinsic prothrombin activator, which is responsible for initiating the process of clot formation.